Welcome to the last section for Math 140. Congrats, you have made it. Okay, so we are looking at shifted conics. Well, previously, we've been looking at conics that were all centered at the origin or centered at 0, 0. Now we're taking a look at when we shift those around on the graphs, sort of like transformations. So shifting graphs of equations. If h and k are positive real numbers, so h and k, then replacing x by x minus h or x plus h, and replacing y by y minus k or y plus k has the following effects on the graph of any equation in x and y. So if we subtract h from x, what do we get? Well, we go right h units. Now, if x is replaced by x plus h, so for adding h to x, then we move left h units. If we subtract k from y, we go up k units, and if we add y to k, or k to y, what happens? Well, we go downward k units. Okay, kind of interesting, because it kind of looks like we do the opposite sometimes of what the direction is doing, but there we go. So example 1, sketch the graph of the ellipse. Okay, so we're told it's an ellipse, but how else would we know? Well, we have our x value squared, our y value squared, a plus symbol, and it's equal to 1. And the values on the x and the y are two different numbers, so because of that we know it's an ellipse, even if they didn't tell us. Okay, so the basics of our ellipse will be the same. We have the b value and the a value. So the a value is always the larger one when we're looking with the ellipse. So that means our a value is going to be, or our a squared value is going to equal 9, and our b squared value is going to equal the 4. So we know that. But then, notice at the top we have some shifting going on. So since we have some number being subtracted from the x, what do we know? And I'd like you to write these down on your work for your exams. So we know, because of this, subtracting the 1, we're going to move right. Let me go ahead and write that out. Move right. How many units? Move right 1 unit. And then, on the y, what do we have? Well, we have a plus 2. So when we add it, it means we're going to go downwards. So we're going to move down, how many units? 2 units. Okay, and there we go. We have the changes. Please make sure to state those clearly. That is definitely something I grade for. Alright, and then what else do we know for the ellipse? Well, remember, the main things we need to find for the ellipse are our a and b values. Let's go ahead and just real quick simplify that. So plus or minus 3, plus or minus 2, and then what else do we need to know for our ellipse? Well, usually we could find our foci and our vertices if it was based at the origin. But notice, remember, we've shifted. So how can we find the center, the vertices, and the foci? Well, for the center, easiest way is to just go ahead and take the zeros from these values in here, just like you would with a circle. So the center, let me go ahead and state it here, center is going to be at 1, negative 2. Once again, remember you take the opposites for the center, just like you would with a circle. And circles, you did that more than likely in Math 103 or Math 135. Okay, so now we still need to find the foci and the vertices. So what we're going to do first is to find the unshifted foci and vertices, using the same methods we used previously, and then we'll apply the shifts to those values, like we would do usually with transformations, to find the shifted foci. So let's go ahead and do that. Let's do unshifted. Let me fix that. Shifted foci. So the unshifted foci, that comes from the c squared minus c squared equals the a squared minus the b squared. So then c is going to equal plus or minus the square root of 9 minus 4. So c equals plus or minus the square root of 5. Okay, so this is the unshifted one. So how should we write our point? Well, because the y value had the larger value underneath it, because of that, we know we're going to be looking at a y coordinate. So this will be 0 plus or minus root 5. However, that's the unshifted foci. I want the shifted one. So, for my shifted foci, what we do is we're going to add the shift to it. And what affects the y values? That would be moving down or up. Those are affecting the y values. So we're going to add 2 to it and then subtract 2 to it. Okay, so adding 2 or subtracting 2 will get the actual foci. Okay, so applying the -2, we'll get 0, -2 plus the root 5, and then the 0, the -2 minus the root 5. Okay, so that was for the positive and negative root 5, which is why we have those two separate options. Now, next thing to do, slightly running out of space, but let's go ahead and write down unshifted vertices. So for the vertices, if you recall, those are going to be 0, and then they are the a values. This is for the unshifted. So it'd be plus or minus 3. And be careful with your labeling here because we are working with different values. And then, so the vertices, the ones that are shifted, well, what do we shift the a values by? We're shifting down 2 units from positive or negative 3. So that'll be 0, and then -2 plus 3, so that'll be 1, and then the 0, -2 minus 3, so that'll be -5. Alright, actually let me go ahead and include all of this. So this here is our important information. Alright, let's go ahead and graph this. So we have our center at -1, or sorry, 1, -2. 1, -2. And then we have 1, 1. And then 1, -5. And 2 more points to go in. 3, -2. And lastly, -1, -2. And drawing in our ellipse, make sure there are some nice curves going on. Shouldn't be angular. And there we go. We have our shifted ellipse. As usual, it's easier to find the values before you've shifted them and then apply the shifts to them, just like we were doing with transformations. Now let's look at parabolas. Okay. So as usual, we have the 2 different types of parabolas. We have the ones that are focused on the vertical, and then ones that are focused on the horizontal. And along with that, we have ones that shift upwards, like this one does here. It's shifted up from the origin, and this one, that goes down, up or down from the origin, and then this one that opens right or left. And all of these shift from the origin in different directions. So in general, there are actually 4 options for parabolas. Okay, and that has to do with the sign, which tells you if it opens up or down, or left or right. And then if it's x squared or y squared. Okay, example 2. Determine the vertex, focus, and directrix of the parabola. Sketch the graph. Well, first off, how do I know that this is even a parabola? If we look at our variables, we only see an x squared. We don't see a y squared. So I know this must be some form of a parabola. So let's go ahead and get this in the correct format for a parabola. And what would the correct format be? Well, it's supposed to be our x value squared equals 4p times y. However, these are talking about the parabolas that are shifted. And how do I know that this is supposed to be a shifted one? Because I have an x to the 1 value. Notice in our original formula, we don't have an x to the 1 value. So because we have an x to the 1, we know this is a shifted parabola, and it's not centered at the origin. How do we figure this out? Well, we're going to have to complete the square. Another skill from Math140. Okay, so to complete the square, I'm going to go ahead and take half of that value right there. So -2 divided by 2, and then square it, and what do we get? We'll get 4 divided by 4, which is going to be 1. Okay, so we have a positive 1. Alright, so we would add that positive 1 to both sides. If you need a refresher on completing the square, please just send me an email and let me know. Then we get x squared minus 2x plus 1 equals 8y. And we have the 25 and the 1, so it's minus 24. Okay, so then we can factor this into the identical pair, x minus 1. Okay, so you might say, well, why did we complete the square? Why did we do this? Recall, we're trying to get our x values squared and get it into this format. So once we've done that, we now have our x values squared, which was the goal. Okay, so now it's almost in the perfect format. What are we missing? Well, we need to have, as you can kind of see up here, we need to have our y by itself. Okay, so let's go ahead and do that. X minus 1 squared equals, and we'll factor out that 8, and then we get the y by itself minus, well, that's going to be 24 times 8 would have been 3. Okay, so now this is in the perfect format. We have our y, and we can perfectly see the k value being subtracted from it. And then we have our x value being squared, and then our 8 on the outside, which will be the 4p value. Okay, let's go ahead and find the information. So what would our vertex be? Well, that's just going to be taken from the center values, right here and right here, so that'll be at 1, 3. Next, we need to figure out our p-value so we can find our focus and directrix. So we'll go ahead and find the original one using the original formula, and then we'll go ahead and find it when it's been shifted. So unshifted, we know that 4p should equal 8 from there, which means that p equals 8 divided by 2, which is 2. So that means we would have a focus of 2 and a directrix equal to negative 2. Once again, we're just using some of the old formulas we've had before. Now these are the unshifted values. So I want to find the shifted ones. Well, how is our parabola being shifted? We should have stated that a little earlier, but so let's see. We have a shift of, let's see, we had that minus 3. So we have right 1 unit, comes from right there. And then we have down, up. Up 3 units. Okay, so those were the shifts. Forgot to mention we need to write those down. Okay, so these shifts we're going to apply to our focus and directrix. Alright, so that means our focus, the usual point is at 0, 2 for our focus. Right here, 0, 2. But we're shifting right 1 unit, so that means we're going to add 1 to the x values. And then we're shifting up 3 units, means we're going to add 3 to the y values, so we'll end up with 1, 5 for our focus. Now the directrix, that is the line y equals negative 2. And so for our shifted directrix, what affects that? The shifting up or the shifting right? Well, the directrix is going to be affected by the shifting up, so we're going to go ahead and add 3 units to the negative 2, and we'll get y equals 1. Alright, and there we have the main values. Let's go ahead and box them as the main one. Make sure to state whether your values are the unshifted ones or the shifted ones. So now let's go ahead and graph this. So what do we have? Let me change my pen color. Now we have our vertex is 1, 3. So 1, 3. And then our focus is 1, 5. 1, 2, 3, 4, 5. And then we have the directrix of y equals 1. And that is that line that we draw in, straight as possible. Make sure to label it y equals 1. And then we can go ahead and draw in the points. Ooh, but we're missing something. We need to figure out the other 2 points for our graph. And how do we find that? We need the focal diameter. I forgot to find that. So the focal diameter is going to be 8. And how did we find that? If you recall, it is the absolute value of 4p, which is going to equal 8. And that way we can find the other points. So it's 4 on either side from my focus. So let's go ahead and add 4 to either side of the focus. 1, 2, 3, 4. 1, 2, 3, 4. And then find those points. So let's see. 5, 5. And then 1, 2, 3, 4. Oh, should have been 1, 2, 3, 4. Yeah, 3, 5. And there we go. Go ahead, draw those in. And we have found a shifted parabola. As usual, easiest to find the unshifted values and then add the transformations to them, like we've been doing all along. Alright, so now let's take a look at hyperbolas. Alright, so as usual, we're now looking at ones that are shifted away from the origin. So we might have an x minus h, or minus k, and minus h minus k. And notice here the real quick difference. This is the subtraction between the x and the y, and the other one, the x is the negative. And that changes the way the direction is. So when we have the y as the negative, we open in this direction, like we learned previously, and then when the x is negative, we open in this direction, like we also learned previously. Okay, so find the center, vertices, foci, and asymptotes of the hyperbola. Sketch the graph. Alright, at the moment, this equation looks nothing like we know. How do I even know it's, a hyperbola or anything? Well, I do see that we have an x squared and a y squared. But that means it could be either an ellipse, a hyperbola, or a circle. Since the number in front of the x and the y are different, it's not a circle. That leaves either an ellipse or a hyperbola. Okay. And then we have the main thing is the subtraction. So I know it must be a hyperbola. Alright, so let's go ahead and get this in the proper format or setup to be able to discover what our shifts are. Which means we're going to have to be doing a lot of completing the square. Okay, so let's go ahead and get that 5 to the other side, and then group the x's and the y's. Once again, I'm assuming that you remember how to do completing the square from one of the previous math courses where it was taught. If you don't remember, just go ahead and send me an email for some reminders. Okay, so completing the square. For the 2, we'll go ahead, divide it by 2, and then square it. That'll give us a 1, so we'll go ahead and add 1 to both sides. And we might ask ourselves, do we need to complete the square for the y? The answer is no. There is no y to the first power. Since there is no y to the first power, we don't have to complete the square for the y. Alright, so after we do that, we'll end up with x plus 1 squared minus 4y squared equals negative 4. Okay, so we need to have two other things done. We need to have a 1 on this side, and we need to get rid of that 4 by the y squared. So let's go ahead, divide everything by negative 4. That'll take care of two problems at once. And then we end up with, so that's going to be a positive y squared minus x plus 1 squared divided by 4 equals positive 1. Okay, so now this is in the proper format, and we can determine what kind of shifts we have. Okay. Well, the only shift we have is actually going to be on the x values. So that means we're going to go ahead and we're going to shift left 1 unit. Okay, so that's our shift. Now the next things that we need to find. We need to find the center, the asymptotes, and the vertices, as well as the foci for this. Okay, let's go ahead and find the unshifted versions, and then we can find the shifted one. So for foci, we need a squared and b squared. And we're using the plus value because this is for hyperbola. So the a value, let's go ahead and rewrite this, is going to be 1. So we have c equals plus or minus the square root of 1 squared plus the 2 squared, which would be 4. C equals plus or minus the square root of 5. And we have that. So our original foci, that's unshifted, would be, let's see, that's going to be the 0 plus or minus root 5. But remember, we need to find the shifted one. And we're shifting everything to the left 1 unit, so that'll be negative 1 plus or minus root 5. Okay, so we found the foci. Now we need the center. And we can find that easily right off of the equation up here. That would give us a 0, and that would give us the negative 1. So we'll have negative 1, 0. Now we need the vertices. So for the unshifted vertices, we'll get it from right here with the y, and that would be 0 plus or minus 1. But for the vertices, when we shift, we're shifting left 1 unit, so we'll subtract 1 from the x values and end up with plus or minus 1. Now, after that, we need the asymptotes. Ooh, that is something I forgot to mention in the very beginning. The asymptotes for each of these equations. For the a value, it's going to be y minus k equals plus or minus b divided by a, x minus h. And then for the b value, the asymptote would be y minus k equals, switching the a and b, x minus h. And these are asymptotes. Alright, so filling that in for our asymptotes, we'll end up with y equals plus or minus 1/2 x plus 1. Okay, and there we have our information we need. Oh, and I forgot to mention the a and b. A is equal to 1 and b is equal to 2. Okay, so plotting those items, let's see what'll I get. Center 1, 0. Negative 1, 0, and then we'll go ahead and graph with their boxes. So we have bop, boop, and then doop, doop. That's our box. Alright, now we do our asymptotes. Following along the box, we know it's going to be down 1 over 2. Make sure to try and make it dotted. Alright, let's go ahead and label that. So we have the positive version for the slope and the negative version for the slope. What else do we need to graph? We got to go ahead and graph in the vertices and the foci. Okay, so it's supposed to be at 1, 1. So we have negative 1, negative 1, negative 1, 1. And then our foci. Let's go ahead and change that to a different color. Negative 1 plus or minus square root 5 is a little bigger than 2. So 1 plus or minus square root of 5, that should have been a negative 1. And then the negative 1, minus square root of 5. That one should not be a plus or minus, it should just be a positive. Okay, and then we can go ahead and sketch in our graph. I'm going to go ahead and do that in yellow, and we're done with this one. Definitely a lot of work goes into doing these. So just take your time, make sure your work is carefully labeled so you don't get lost in your own work. I have done that before. And we're done. Alright, let's take a look at the next thing. So now we have general equation of a shifted conic. Okay, so if we have the graph of the equation, ax squared plus c y squared plus dx plus ey plus f equals 0, where a and c are not both equal to 0, so that means we need to have a and c. This is a conic or a degenerate conic. In the non-degenerate cases, the graph is a parabola, ellipse, or a hyperbola. And it's pretty much all the stuff that I've been talking about before. So for parabola, it's if we only have one x squared or one y squared. It's an ellipse if a and c have the same sign, so they're plus and minus, which means we also have both the x squared and the y squared. And it's a hyperbola if they have opposite signs, but we still have the x squared and the y squared. Okay, so definitely look for the x squared and the y squares and look for the signs. That'll tell you which one it is. So now we have example 4. Sketch the graph of the equation. And notice, we're not told what it is. And more than likely, that is the way it's going to be for the final. So sketch the graph of the equation. Well, let's see. I always look for the squared values. And notice, how many do we have? We only have 1. So what do you think this is going to be? This is going to be a parabola. Okay, so since we know it's going to be a parabola, and the x is squared, I'm going to go ahead and try and get this into the proper form, which means I want the x's on one side and the y's on the other. Okay, and then I need to complete the square. Why? Because remember, the form for parabola is x squared equals 4py, or some value squared, plus or minus that number. Oops, let me rewrite that. Or x plus or minus some number equals 4p and then y plus or minus some number. Okay, so we got to go ahead and complete the square. So to do that, with my scratch work on the side, I'll take that 6 divided by 2 and then square it. So 6 divided by 2 is 3, squared that is 9. So we'll add 9 to both sides because we're completing the square. And then we'll get x squared plus 6x plus 9 equals negative 12y plus 0. The 9's cancel each other out. Okay, so then rewriting that, we'll have x plus 3 squared equals negative 12y. Okay, so it definitely is a parabola. So what do we need to find for the parabola? Well, we need the vertex, which we can easily pull off from right here, the 3, and since there's nothing with the y, we'll assume it's 0. Okay, so we have negative 3 comma 0 for our vertex. And then, let's see, we have to find our focal diameter. Okay, to find that, we'll take 4p, which we know should equal the negative 12, which means p equals negative 3. Okay, so since p equals negative 3, we know that our parabola is going to open down, since it's a negative. And that means our focal diameter. Okay, and now we can find the unshifted focus and directrix. Unshifted, we have the focus and the directrix. Okay, so the focus would be at negative 3, 0, and our directrix would be at y equals the opposite of negative 3, which is 3. Okay, so now we have to check to see how our graph is affected by the shift. So what shifts are happening? Well, the only shift we have is actually affecting the x value. Nothing's happening to y. So with that plus 3, what does that mean? We're going to shift left 3 units. So our x values are going to be affected, so we're going to subtract 3 from any of our x values, which is why our vertex was negative 3, 0, because usually it's at the origin. And then our focus is going to be at negative 3, negative 3. And then let's see our directrix. That does not get affected by shifting left or right, so it's still going to stay at y equals 3. Already have those values. The next thing we need to do after we graph those is just find the remaining 2 points. Okay. So, and to find, those remaining 2 points, we would need to know the focal diameter, which we do. It was 12, which means we're going to be moving left or right half of 12, which is 6 units. Okay, so let's go ahead and put in our vertex, negative 3, 0. And then we have our focus is at negative 3, negative 3. Directrix is y equals positive 3, 1, 2, 3. And let's see, the only thing we need to find now is the other remaining points. So moving 6 from our directrix on either side, 1, 2, 3, 4, 5, 6. What is that point going to be? That will be 3, negative 3. Moving 6 the other direction. 1, 2, 3, 4, 5, 6. And that point is going to be at, let's see, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like it's 9, negative 3. And there we have all of our important information for graphing a parabola. Once again, you will not be told what the equation is you're graphing, so you need to decide that in the very beginning before you start finding the information. So now let's look at the last example for this section and for the course. Huzzah! Alrighty, you have made it thus far. Good job. Okay, so sketch the graph of the equation. Well, first off, what is it? They don't tell us. Let's look at any x squared and y squared values. We have an x squared and we have a y squared. So it's either a circle, an ellipse, or parabola. However, we have a subtraction. And the number in front of the x and the y is different, which means this is going to be a hyperbola. Alrighty, so let's go ahead and start getting this in the correct form for a hyperbola. Okay, so at the moment, we have this, and what form do we need to get it into? Well, it needs to look like something plus or minus a number squared over a number plus y plus or minus something squared over a number equal to 1. That's our goal. Okay, to do that, we're going to have to complete the square. So let's get the x's and the y's together. And then before we do that, we need to have the y's to the first power in order to complete the square. So we have to take out that -9. Definitely pulling on the old skill of completing the square. Okay, and then when we complete the square, take half of this value, then square it. So that would be 9. We have to add 9 to the other side. And again, completing the square for this one. Half of that value, that'll be -1. Square it would be +1. However, we have to be careful before adding 1 to the other side. We need to recall that this -9 is hanging out there. So because of that -9, if I was to multiply this out, I would have actually added a -9 to this side of the equation. So to balance that, remember we're all about balance with equations, we have to subtract 9 from this side. We're not going to be adding the 1. Why again? Because of that -9. Okay, so that means this goes to what? To 0. And then let's go ahead completing the square, so +3 squared plus that -9, actually let's not do plus -9, -9, y minus 1 squared equals 0. And then we need to get rid of that -9 being multiplied, so let's go ahead, divide everything by the -9. And what do we get? We get, rewriting things a little bit, y minus 1 squared minus x plus 3 squared over 9 equals 0. And that is over 1. We have a problem, Houston. What's wrong? That's a 0. Remember, my equation should always have a 1 on the side. And we can never get it equal to 1 on that side. This is an interesting type of hyperbola. This is what we call a degenerate hyperbola. A degenerate hyperbola, because we could not get it equal to 1 here. So what do we have, since this is not actually a normal hyperbola? Well, if we tried to solve this, so if we continued on, we have that y minus 1 squared over 1 equals the x plus 3 squared over 9. So notice I just moved the x values over. I added them to both sides. So I'm continuing solving, and let's see, if I solved for x, I could go ahead, square root both sides. I would end up with x plus 3 divided by 3 equals y minus 1, or x plus 3 divided by 3 equals negative y minus 1. Now, what would these each be? Kind of running out of room here, but we would get, if I continued to solve this, I get y equals x over 3 plus 2. And from this one, I would get y equals negative 1 over 3x. These are equations of two lines. So our degenerate hyperbola, actually, when we continued solving for y, we ended up with the equation of two different lines. Let's go ahead and graph our answer. So let me just go ahead and rewrite it up top real quick so we can see it. We had y equals negative 1/3 x and y equals 1/3 x plus 2. So graphing the two of these, let's see, one is at 0. I'll graph this one first. So that'll be negative 1 over 3. Okay. So graphing that one in. Ooh, that was, wait, let me fix my line. So graphing it in, and then let's go ahead and graph the other one. I'll do a different color. And then we have the 1/3 plus a half. So it starts up at that positive 2, and then we have a slope of positive 1 over 3. Aha, we see where they intersect. And there we have our graph of the equation. It was a degenerate hyperbola. How did I know that? It equaled 0. So what did I do? I continued to solve for y to find the equations of two lines. And there we go. That is it for 1.4, and that is it for Math 140. Please email me if you have any questions.